Hi everyone. In this chapter we're going to be looking at systems of linear equations. In this lesson we will be looking at solving linear systems by elimination.
So the method of elimination is our second algebraic method for solving linear systems. And even though I think the explanation here is maybe a little bit more awkward than it is for substitution up front, I get the impression that most people are probably going to kind of get attracted to this method as opposed to doing substitution, just because I think there's some things here that are just a little bit easier to see once you get used to what's going on here. So the method is, or the idea of elimination is essentially the same as substitution. What we're going to do is try to take the two equations with two variables and reduce it to one equation with one variable. Okay, but we do that in this case by combining the equations in a little bit more of a direct way. So what we're going to do is the same thing as before. We're going to choose a variable, but this time we're going to choose a variable to eliminate by combining equations. And to do that, we need to make sure that the coefficients are the same. So you're looking for, initially, between the two equations, one of the variables that has a shared coefficient. Now, if one of the coefficients is positive and the other one is negative, okay, then we're going to add to eliminate that variable. And just think of it like this. If you had like a -2 plus and a +2, you'd have to add them together. -2 plus +2 is 0. That would eliminate that variable. If both of them are positive or both of them are negative, and this is the one that causes probably the most difficulty with this, okay, but you're going to subtract. Basically, if the signs of the two coefficients are the same, you subtract them. And now, so think of it like this. If you had, for example, a -3 and a -3, how do you get rid of those numbers? How do you create a 0 out of this? Well, you don't add them. -3 plus -3 is -6. If you want to eliminate those, it has to be subtract that -3. So -3 minus -3, there's where my 0 is coming from. Okay, but right here, this pattern is going to cause probably the most difficulty. Okay, and we're all aware of that. We all know that working with negatives can be a little bit confusing. But just as you're working through these problems, if you really want to help yourself out, when you see those negatives pop up, just take your time and ask yourself, am I doing this correctly? Okay, am I applying the right operation? Just be very deliberate when you see negative signs show up. Now, that's the right method if the coefficients are the same. But if they're not, okay, then what we got to do is the same thing. We got to choose one of them. Then we got to do something else here. Now, what we're going to do is we're going to multiply all the numbers in one equation by some number to make either the x coefficients or the y coefficients the same. Now, at this point here, one of the misunderstandings that people have is they think that you have to multiply both equations by that same number. And that's not true. You can just pick one of the equations, multiply it through by whatever number you need to make the coefficients the same. Or if you have to, maybe what you do is you multiply, like it says here, both equations by different numbers to make those coefficients the same. In a way, it's kind of like working with fractions. You're looking for that least common denominator. In this case, you're looking for that least common multiple of the coefficients that you've got to find a number that makes those coefficients the same. Now, this might be a little bit confusing until we take a look at some examples here. But the goal is to take a system where the coefficients of a variable are different and make them into a system where the coefficients are the same, so that you can then make it into a single equation with a single variable that you can then solve. Okay, it's a little bit of a path that you got to follow there, but it'll make a lot more sense after a couple of examples.
Solve by elimination. 2x plus y equals -7. X plus y equals -5.
Okay, so here we go. So here's equation 1. Here's equation 2. I take a quick look to see what the coefficients are, and I notice right away that the coefficients of the y variable are the same. So what I'm going to do, I'm going to draw a line underneath it here, and then I'm going to give myself a little bit of a visual clue as to what I'm doing. This will help your teacher, if you do it this way, this will help your teacher know what you're attempting to do if you make a mistake, okay? So because the coefficients are the same, they're both positive here, I'm going to take equation 1 and I'm going to subtract equation 2. Okay, so Now just watch this. 2x minus x is x. Positive y minus positive y is 0, and that's what I wanted. I wanted to eliminate the y variable here because the coefficients were the same. Now be careful with this one. Negative 7 minus negative 5, okay, is going to be negative 7 plus 5, negative 2. And there it is immediately. I already know what x is. I don't even have to do anything. Okay? So right there, the answer kind of fell into my lap. X is equal to negative 2. Now what I got to do is sub one of those back into an original. So sub into an original, because I want to figure out what the y-coordinate is. Now at this point in the method of substitution, this was a little bit more obvious. It was easy. You picked the little equation that you'd solve for. Here, not so much. It's basically wide open. You just got to pick one. And in this case here, we'd probably pick number 2 because the coefficients are a little easier here. So we're going to go into we're going to substitute into 2. And so that'll be negative 2 plus y is equal to negative 5. So bring the negative 2 over, add it to both sides. So negative 5 plus 2 is going to be negative 3. And so there's my solution. Okay? So therefore, I am getting the point negative 2, negative 3. Now, I should probably check that though. Sorry, I'll put my solution over here, my little solution spot. Negative 2, negative 3. Remember to put it in parentheses. Okay, gotta put parentheses around that or else it's not a point. It's just a list of numbers here. But we're going to check this. Now, I had used equation 2 to get the y-coordinate here. So I'm going to check this in equation 1, make sure it works in both. So 2 times negative 2, there's my x-coordinate, 2 times negative 2, plus negative 3, there's my y-coordinate. So let's see what we get here. 2 times negative 2 is negative 4, plus negative 3, well, negative 4, plus negative 3, negative 7. And look back at the original, that's what I'm supposed to get. So good. That's correct, which means that is the correct solution to that system.
Solve by elimination. X minus 2y equals 7. 3x plus 2y equals 5.
Okay, so now for this system, let's take a quick look here. Let's label it again. Equation 1 and equation 2. Now, I'm going to draw a line underneath here. Let's take a quick look. I'm going to investigate the coefficients to start off with. 1 and 3. But 2 and 2 in front of the y's here. And notice that they're different signs. They're already opposite to each other. So all I really need to do is just add these equations together. So I'm going to give myself, my instructor, just a little bit of an idea as to what I'm doing. So x plus 3x will be 4x. Negative 2y plus 2y, those are opposite. They cancel each other out. 7 plus 5, 12. Now the answer hasn't completely fallen to my lap, but we're really, really close here. Divide by 4, and I get that x is equal to 3. Perfect. Okay, so now we're going to sub into an original. And it doesn't really matter which one we're going to go into. I mean, equation 1's got a no coefficient, or a 1 in front of the x, but it's got a negative in it. I don't know. It's whatever you want here. I'm going to go into equation 1. So this will be 3 minus 2y is equal to 7. I'll bring the 3 over. So 7 minus 3 will be 4. And I don't know why I wrote that like that. Sorry, it's negative 2. And when you divide by negative 2, you get negative 2. Which means, therefore, my solution is the point 3 comma negative 2. And I'll put that over here in my little solution box here. A little solution, oops. Why am I doing that? That's so weird. There we go. Now, but I gotta check it. Make sure I did it right here. Now, again, I used equation 1 to get that final value. So I'm reasonably confident that the point works in equation 1. So I'm going to check this in equation 2. So that'll be 3 times 3. There's my x value. Plus my equation tells me to multiply 2 times y, so negative 2. Okay, well 3 times 3 is 9. 2 times negative 2 is negative 4, so 9 and negative 4 is 5. And that's what I was expecting. Good. So that is the correct solution to that system.
Solve by elimination. 3x minus y equals 11. X plus 2y equals 6.
So for this system, let's label this 1 and 2, so we know what we're talking about. When you take a look at the coefficients here, notice that there's nothing that matches up. Okay, so this is not just a simple process of adding or subtracting these equations. We now have to adjust something here to make it work. So what we're going to do here, actually, I'm going to draw the line here, but, and I can do this a couple of different ways here. But what I'm going to do to start off with here is I'm going to pick a variable, and I'll pick x in this case because I want you to see that you can actually get rid of whatever variable you'd like. So I want the coefficients of x to be the same. So what I'm going to do is I'm going to take equation 1. I don't really need to do anything with it. It's got a 3 in front. You know, I wish it was maybe a 1, but 3 is fine. So 3x minus y is equal to 11. And I'm going to take equation 2 and I'm going to multiply that by 3. Okay, so this is my indication. I'm going to multiply by 3. So it'll be 3x plus 6y is equal to 18. And so now what I'm going to do is I'm going to write equation 1 minus 3 times equation 2. So 3x minus 3x, 0, goes away. Now be careful with this. Negative y minus 6y is going to be negative 7y. 11 minus 18, negative 7. And again, the answer didn't fall completely in my lap, but really close there. So divide both sides by negative 7, and we get that y is equal to number 1. So now we're going to sub into an original. Okay, y equals 1. You know what? Probably the first equation would be one of the easier ones to work with here, or the easier one to work with. So this is going to be 3x minus 1 is equal to 11. Okay, bring the 1 over to the other side, so we get 3x is equal to 12. Because remember, there's two terms here. I got to get it down to the one term with the x in it. So I got to remove everything that doesn't have an x in it. And now let's divide by that coefficient. This is 3 times x equals 12. So let's divide 12 by 3. And we get 4. So therefore, our solution here is the point 4, comma 1. And so I'll put this over here on my little line. There's my solution in parentheses. But I'm going to check it. Pretty sure that's the answer, but we're going to check it. We used equation 1 to get my result there, so we're going to check this in equation 2. And so that tells us 4 plus 2 times 1. And let's just think about this. 4 plus, well, 2 times 1 is just 2, so 4 plus 2 is 6. And compare that to the original equation 2, and that's exactly what we were expecting to get. So that is the correct solution.
Solve by elimination. 3x minus 3y equals 7. 5x minus 6y equals 8.
Okay, well, to solve this system, first of all, we're going to label. Let's label these guys. And now we investigate the coefficients. Okay, 3 and 5. Yeah, 3 and 6, though. Okay, well, that's okay. Because to make those the same, all I really got to do is multiply this one by 2 here. So I'm going to create a brand new system. I'm going to multiply the first equation by 2. So, I am multiplying the first equation by 2. So 6x minus 6y is equal to 14. Now, one of the more common mistakes that gets made at this point is you multiply the coefficients by that new factor there, but you forget the constant. Okay, see a lot of people that'll do this. They'll make this 6x minus 6y, but they'll forget to make that 14. They'll leave it as 7, and that's where the mistake gets made here. Equation 2 was okay. Didn't really need to do much with it. Okay, and so now I'm going to combine these two. Now notice, because the operations in front of the 6y are the same, what I need to do is I need to subtract these two. Okay, now if that's not clear to you, right off the bat, you need to be very, very careful with this. I'm going to take 2 times equation 1 and I'm going to subtract equation 2. So 6x minus 5x is just x. Negative 6y minus negative 6y. It will minus the negative is addition. So negative 6y plus 6y, 0. And then 14 minus 8 is 6. And so there we go. There's my solution. And in this case, it falls right into my lap. But I got to make sure that I'm doing that subtraction correctly here. Okay, so now we're going to sub into an original. Doesn't matter which one. Actually, in this case, it really doesn't matter which one because they're all kind of equally ugly. But the numbers in equation 1 are a little bit smaller to start off with. So we're going to do equation 1. So that'll be 3 times 6 minus 3 times y is equal to 7. So we got 18. But you know what? I got to bring that over. I'm going to bring that over. So 7 minus 18, okay, is going to be negative 11. And so y is equal to negative 11 thirds. Now I'm going to double check this because last time the fraction popped out, turned out it popped out like that because I had done something wrong here. So let's take a quick look here. Multiply by 2, so 2x minus, 6x minus 6y equals 14. Yep. And now we're going to subtract. 6x minus 5 is x. Negative 6y, okay, well that's going to go away. 14 minus 8 is 6. Yep. Okay, well that looks like that's the solution we're supposed to be getting then, but it's always good to check. So y is equal to negative 11 thirds. And now we're going to, oh, sorry, that's my, sorry, I was going to say now we're going to do something else here, but that's my solution. So therefore my solution is the point 6 comma negative 11 thirds. So down here, 6 comma negative 11 thirds, and we're going to check it. And because I used equation 1 to get that answer, I'll check this in equation 2. So 5 times 6 minus 6 times 11, negative 11 thirds. Oh, sorry, positive 11 thirds. My mistake. Okay, I did screw up a little bit here. Sorry, a negative divided by a negative is going to be positive. Sorry, that should have been a negative. Sorry, positive. Man, I keep wanting to say that. What the heck? It is, however, first thing in the morning, and I haven't had my intake of caffeine yet, so that could be the issue. So let's see what happens here. 5 times 6 is going to be 30 minus, okay, 6 times 11 thirds. Well, the factor of 3 and 6 is going to cancel. We'll be left with 2 times 11, 22. So 30 minus 22, okay, is going to be 8. And that's actually the number that we were looking for. So that is true. The 11 thirds was the correct answer there. So yeah, so 6 comma positive 11 thirds.
Solve by elimination. 2/3 x minus 1/2 y equals 4. 1/2 x plus 1/4 y equals 5/2.
Okay, well for this system right here, perhaps the first glance at this is a little terrifying because of all the fractions here. Again, we're going to label this equation 1 and equation 2. Well, it should be clear that the first thing we're going to do here is get rid of the fractions. Now, the truth is, quite honestly, I can make this go away. If I multiplied this second equation by 2, then the coefficients of the y's would be the same. However, I would still be working with fractions. I'd still have to deal with fractions up here. And I know most of us don't want to do that. Most of us get really intimidated when we see that. Okay? I wish it wasn't the case, but it is the case. So what we're going to do to start off with is we're going to pick common denominators, and we're just going to change these equations here. So between 3 and 2, there's a common factor of 6. So I'm going to multiply equation 1 by 6. Okay, so 6 times 2/3 is going to be 4. So it'll become 4x. 6 times negative 1/2 is negative 3. 6 times 4, 24. Okay, good. Same equation, really is. I just multiplied by a constant, and when I did it to both sides, it's the same thing. I haven't done anything to it, but it looks better. Here, in equation 2, if I multiplied by 4, that should do it for me. 4 times 1/2 is 2. 4 times 1/4 is 1. Well, that's a nice one. Okay, and then 4 times 5/2 is going to be 10. Okay, now I tell you what, I'm going to relabel these equations because I don't want to keep working with the 6 and the 4 up front. So I'm going to label these things 3 and 4. And now that's the system I'm going to work with. So here we're going to kind of break this up here. I'm going to work now with equations 3 and 4 here. Now let's take a quick look. Look at the coefficients. And actually, it would be just as easy to do one or the other here. But you know what? Let's get rid of the x's. Okay? Because to do that, all I got to do is multiply this equation 4 by 2. So here's equation 3. It'll be 4x minus 3y is equal to 24. And if I multiply equation 4 by 2, I will get 4x plus 2y is equal to 20. Now, to get rid of the x terms, all I really got to do is take equation 3 and subtract the 2 times equation 4. 4x minus 4x goes away. Wonderful. Now, negative 3y minus 2y is negative 5y. And 24 minus 20 is going to equal 4. So y is an awkward negative 4/5. Okay? Now let's just double check that everything, because this fraction popped out. Let's just make sure that we've done everything correctly here. So multiply that first equation through by 6. 2/3 of 6 is 4. Half of 6 is 3. 6 times 4 is 24. Looks good. Multiply the second equation by 4. Half of 4 is 2. Quarter of 4 is 1. And then 4 times 5 halves is 10. Okay, multiply through by 2. Did I multiply through everything by 2? 2x becomes 4x, y becomes 2y, 10 becomes 20. Yep. So maybe I subtracted wrong. Well, the 4's go away. Negative 3 minus 2, negative 5, 24. Okay, well, negative 4/5 looks right. Now, I should be a little bit cautious, but everything looks in order, so I keep going. So now we're going to go back up to here, and we're going to sub into an original. Okay. It doesn't really matter which one we plug that into, but I suspect because of the nice numbers here, the 2's and the 4's, people probably are going to want to go into equation 2. So let's make this will be 1/2 x plus 1/4, and now the y coordinate that I got was this negative 4/5. So negative 4/5 is equal to 5/2. So 1/2 x minus, because it's a positive times a negative. Well, the 4's will cancel, but that doesn't eliminate the fact that I've still got a fraction. Okay? Still got a fraction in there. Now, I could, and I probably should, take a moment to make that look better by just multiplying by, again, the common denominator. I can keep doing this as often as I want, because it doesn't change the equation if you do it to both sides. So the common multiple here is 10. So 10 times 1/2 is 5x. 10 times negative 1/5 is going to be minus 2. 10 times 5/2 is going to be 25. Bring the 2 over. 5x is going to equal 27. And so x is equal to, wow, 27/5. Now that's kind of an ugly little number there, but that is okay. Okay, so here we go. Here's our solution. It's going to be 27/5, comma, negative 4/5. So I'll write that in my little solution section here, 27/5 minus 4/5. But now you know what? I'm going to check it. And because I used equation 2 to get that x coordinate, I'm going to check this in equation 1. So 2/3 of 27/5 minus 1/2 of negative 4/5 is, oh, excuse me. Oh, there we go. Oh, wow. Okay, I'm sorry about that. That kind of came out of nowhere. So this is going to be 54/15 plus, oh, okay, this is going to cancel, plus 2/5 is equal to, okay, well, the common denominator here is going to be 15, so this will be 6/15. And 54/15 plus 6/15 is going to be 60/15, which is just 4. 4. And if you look back to equation 1, that's actually what I wanted. So yeah, that worked. That is my solution. There you go. It's a little ugly, but it is the correct answer. Oh, sorry, that looks like sorry, that looks like 51 there. Sorry, that should be a comma there. 27 fifths, comma, negative 4 fifths.
Solve by elimination. 3x plus 2y equals 2. 4x plus 5y minus 12 equals 0.
Hi. Well, to solve this particular equation, first of all, I'm going to label them. Now, I want them to be in the same form. That's just going to be the most useful way for me to work with this. It doesn't have to be in the same form, but I'm going to be less likely to make mistakes if they're in the same form. So this one's in standard form, this one's in general form. So to make it consistent with the work that I've done before, I'm going to take equation 2 and rewrite it just in standard form. This isn't a big change by any stretch of the imagination, but it'll help. So I'm going to bring that 12 over to the other side. So now here's equation 1, here's equation 2. I really haven't done anything. I've just made it consistent here. So now I got to investigate the coefficients here. Now here's an example of an equation where to make the coefficients the same, I'm going to have to multiply both equations. So really it's just a matter of which variable you want to get rid of. And I will stick with y because I think most of us will get rid of y on a more consistent basis. Okay, so now between 5 and 2 here, the common multiple, least common multiple, is going to be 10. So I'm going to have to multiply equation 1 by 5, and that'll get me 15x plus 10y is equal to 10. And I'm going to have to multiply the second equation by 2. So it'll get me 8x plus 10y is equal to 24. Make sure that you multiply everything through by that factor. And so now, what I'll do is I'm going to take 5 times equation 1 and I'll subtract 2 times equation 2 because the coefficients are both the same sign. Okay, it's positive 10, positive 10. And so now 15x minus 8x is going to be 7x. 10y minus 10y goes away, which is what I was expecting. And 10 minus 24 is negative 14. Quick little calculation here. I'm going to divide by that coefficient and we get x is equal to negative 2. Oh, and I'm very happy that it's negative 2 and not some crazy fraction, which is good. All right, so now we move on here. It's the same as we've done over and over again. We're going to sub into an original. Doesn't really matter which one. Let's choose maybe equation 1. So in the original equation 1, this is going to be 3 times negative 2 plus 2y equals 2. So there's negative 6. And when I bring that over, I'm going to have to add 6. This will become 2y is equal to 8, or y is equal to 4. And there we go. We got our point here. So therefore, the point that we were looking for was negative 2, 4. I'll put that in my little solution spot right there. And like I've done before, I'm going to check it. Because I used equation 1 to get the rest of the solution, I'm going to check this in equation 2. And so that'll look like this. Equation 2 says 4 times x, which is supposed to be negative 2, plus 5 times y, which is supposed to be 4, minus 12 equals. Okay, let's see what happens here. So 4 times negative 2 is negative 8. Okay, whoops. Sorry, make that look like a plus. Negative 8 plus 20 is going to be positive 12 minus 12 is 0. And that is exactly what I needed it to be. So there we go. That works. So that is the solution.
A community group purchased 72 cedar tree and spruce tree seedlings to plant for the Earth Day project. The number of cedar trees was twice the number of spruce trees. How many of each type of tree did the group purchase?
So this question right here is asking about how many of each type of tree seedling this group is going to purchase here. So those become my variables here, okay? So we're going to and as I've done before, I'm going to get kind of lazy about this. I'm not going to use really fancy little variables here, C's and D's, whatever it is. I'm just going to let x equal, what is we got here, the number, okay, of cedars, and we'll let y equal the number of spruce. Okay, I'm just going to use x and y because I'm comfortable with those. that's basically it. I'm just comfortable with those. I'm going to stick with that here. So let's take a look at the information that we're given here. So 72 cedar trees and 72 cedar tree and spruce tree seedlings were purchased here. So what that means is that's a total. I don't know how many of each, but I know the total. So I know if I add x and y together, I'm going to get 72. Now this is a great equation to start with because the coefficients are 1. So whatever my second equation ends up being, it's just going to be a simple matter of multiplying this first equation by whatever coefficient I need. Let's take a look at the next bit of information we're given here. The number of cedar trees, okay, that's x. So the number of cedar trees was, now was, is, okay, those are all words used to represent the equal sign. So the number of cedar trees was twice the number of spruce trees. Okay, so there we go. And there's no other information given there. That sentence just ends. So that's it. So here are my two equations, 1 and 2. Honestly, right now this question looks more nicely set up for substitution, but we're going to use elimination here. So what I got to do is I got to make that system look a little bit better first. I got to put this in standard form. So here's my equation 1, x plus y is equal to 72. So equation 2, I'm going to bring that over. X minus 2y is equal to 0. Now, look at my x's here. My x's both have the same coefficient. They're both 1. Really, really easy to work with. So I'm just going to take equation 1 and I'm going to subtract equation 2 from it. So x minus x is 0. Now be really careful with this. There is a negative sign here. That's a trap, okay? That will catch a lot of people here. 1 minus negative 2 is going to be 3. 3y is equal to, and then 72 minus 0 is just 72. Okay, so I've run out of room down here, so I'm going to have to move up here. So dividing both sides by 3, okay, is going to get us 24. Okay, and you can just double check that. 3 times 4 is 12, carry the 1, 3 times, there it is, 72, right? So there you go. Y is equal to 24. Now, if that's the case, I'm going to sub this into an original. Now, by the way, you don't have to keep writing this. I'm just doing this as just a little reminder for you guys as we're going through this. I'm going to sub into an original, either equation 1 or equation 2 here. And you know what? Either one of those would be really easy, but equation 2 is probably the most straightforward here. So I'm going to plug that into 2. X is going to equal 2 times 24. Well, that's just 48. So good. So there's my answer here. The point that I get is the point 48, comma 24. Now, what I should do here before I completely answer this question is just check it. I used equation 2 to get that value, so I can assume that this works in equation, that this point here works in equation 2. So what I'm going to do is I'm going to check this in equation 1. So let's see here. That's got to be 48 plus 24. Let's see what this is equal to. So 8 and 4, 12, carry the 1, 4, 2 is 6. With that extra 1, 72. And that is, in fact, the number that I was expecting. So that is the correct answer. So now, I answer the question. Okay, because you got to remember that when it's a word problem, the point there is not the solution of the problem. I actually have to identify it. So it's asking how many of each type of plant here. Well, X represented the number of cedars. So we know we have, or they bought 48, cedars, and 24, because 24, remember, that's the y coordinate that referred to the number of spruce, and they bought 48 cedars and 24 spruce trees. There you go. Whoops.
Nuri invested $2,000, part at an annual interest rate of 8% and the rest at an annual interest rate of 10%. After 1 year, the total interest was $190. How much money did Nuri invest at each rate?
Hey, so the question here really is just how much did she invest at each rate? Okay, so what we're going to do here is we're going to let X be the money at, well, okay, what two interest rates here? At 8%. And we'll let Y equal the amount of money at 10%, because we have to identify what our variables are before we jump into this problem here. Now, Nuri invested $2,000 kind of total. I mean, that's how much he had there. So what we know is x plus y, the amount of money plus the amount of money, is going to equal the total of 2,000. Now, part of it went at 8%, part of it went at 10%, and after 1 year, the total interest was $190. Okay, well, the interest on that first bit, okay, is going to be 0.08x. The interest on that second investment there is going to be 0.10y. And when we total that up, okay, when we add that up here, we're getting 190. So the way the equations work here is money invested plus money invested equals the total invested. Interest plus interest equals total interest. And so here are our two equations. Now, if you're like me, the decimals here, when you look at those decimals, it's kind of throwing us off a little bit here. So what we want to do is we want to change this system to just make it look friendlier here. So I'm going to take that equation 2 and I'm going to multiply it by 100. Actually, you know what? No, I'll multiply by 100. I will get rid of the decimal. Sorry. No, I will. I was having second thoughts here because if I multiply this one by 10, I'm simply going to get a y. So I'll have a y here and a y here, and I can get rid of those immediately. But then I'm working with decimals over here, and I suspect a lot of people are going to want just nice numbers here. So let's multiply it by 100. So here's equation 1, and we'll multiply equation 2 by 100. So equation 1, nothing needs to happen. When I multiply this by 100, I'll get 8x plus 10y is equal to 19,000. Now don't worry about the fact that the numbers are getting big there over there. It doesn't really matter. Okay, so now to compare these two equations here, and actually I'm going to label this one now 3 and 4 because I don't want to keep writing that 100 there. To make the coefficients the same, I'm going to make the y coefficients the same by multiplying that first equation there by, or equation 3 I should say now, by 10. So if I take, 10 times equation 3, I am going to get 10x plus 10y is equal to 20,000. And here's equation 4 at 8x plus 10y is equal to 19,000. The coefficients of the y are the same, so if I just take 10 times equation 3 and subtract equation 4, so 10x minus 8x, 2x, 10y minus 10y, that goes away, and 20,000 minus 19,000 is 1,000. And so just a little bit of work by dividing by that coefficient, I get that x is equal to 500. Okay? Now, because of that first equation, okay, if I use now equation 1, I can see pretty quickly here, well, x plus y is equal to 2,000. If x is 500, then y has to be 1,500. So I'm getting this point now, 500 comma 1,500. Okay? Now I used equation 1 to get that second value here, so I'm reasonably confident that that point works in equation 1. So I'm going to check in 2. So we're going to get 0.08 500 plus 0.1 times 1,500. Okay, and what do we get there? Well, I'm going to jump to my calculator because I'm lazy. So 0.08 times 500 plus 0.1 times 1,500. And look at that. I get 190, which is exactly the value that I wanted. So that is the correct solution. So therefore, Neary invested, okay, $500 at 8% and $1,500 at 10%.
Louise purchased a Métis flag whose length was 90 centimeters longer than its width. The perimeter of the flag was 540 centimeters. What are the dimensions of the flag?
So this question is asking for the dimensions of the flag. So I'm gonna now I could be using L and W for length and width, but I'm not going to do that. I'm going to let X equal the width of the flag, and I will let Y equal the length of the flag. Okay, so Louis purchased a matey flag whose length was 90 centimeters longer than its width. Okay, now that actually, sorry, it's the perimeter that I wanted. So the perimeter is 540, which means 2 widths plus 2 lengths is equal to 540. Okay, now, before I go any further and even create the second equation here, I'm actually going to adjust this one a little bit. I'm going to divide everything through here by 2. Okay, because I can. I've seen before that I can multiply everything by the same value, same factor, and it doesn't change anything. I can divide as well. And this is going to get me x plus y is equal to 27, or sorry, 270, I should say. So x plus y is equal to 270. Now the reason I did that is because now the coefficients here are just 1, which makes this equation very easy to work with. Equation 2 is going to come from that first sentence there. The length, okay, so the length, that was my y, was 90 centimeters longer than the width. 90 centimeters longer than, okay, is implying an addition here. So it's going to be my width plus 90. Okay, now, once again, this is set up more nicely for substitution than it is elimination, but that's not really all that big of a deal. I'm going to make the system look a little bit better first. So my equation 1 is going to be x plus y is equal to 270. Now I'm going to take that second equation, which is in slope-intercept form, and I'm going to put it into standard form. What I'm going to do here is I'm going to bring the y over and then subtract the 90. So I'm going to do 2 things here, okay? Because remember, in standard form, I want the coefficient of the x to be positive. So equation 2 is going to look like this. It'll be x minus y is equal to negative 90. If I bring the y over to this side, I have to move the 90 over to the other side, and that's going to change its sign. Now, in this case right here, I can basically do whatever I want, because whether I add or subtract, I'm going to end up eliminating one of these variables here. But let's add. First of all, adding is in general an easier operation, and it's going to get rid of the y here. So equation 1 plus equation 2 is going to get me 2x. Y minus y will disappear. 27, sorry, I don't know why I keep wanting to say that. 270 minus 90 is 180. And if I divide by 2, I get that x is 90. And from my second equation here, if x is 90, 90 and 90, that means y is equal to, I should say it like this, from 2, y is equal to 180. Good, so there's my point. Okay, so there's my point, 90 comma 180. But I'm going to check this. Now I used equation 2 to get my y was equal to, so I'm going to check this in equation 1. So equation 1 was 90 plus 180. Now let's just think about that. 90 plus 180, that is 270, which is exactly the value that I was looking for. There's my equation 1, so that is correct. So that means the width of the flag is 90 centimeters, and its length is 180 centimeters.
An alloy is a mixture of metals. An artist was commissioned to make a 100-gram bracelet with a 50% silver alloy. He has a 60% silver alloy and a 35% silver alloy. How much of each alloy must he use?
Okay, with a question like this mixture question, okay, what we're going to take a look at here, well, in this specific case, we're going to take a look at how much silver we're using. Okay, so the question here is really how much of each type of alloy are we going to use here? Well, I'm going to build a little bit of a sort of a chart here. So I'm going to use, this is going to be the amount, okay, so this is, well, maybe we'll say mass, and then we'll say percentage, and then we're going to say silver. Okay, so for the first one, I've got X, and this one here is going to be 60%, and so the amount of silver that I'm getting from that is going to be 0.6x. Then I've got Y, I don't know how much I'm going to use, but this is going to be 35%, and so this is going to be 0.35y. Now, at the end here, what I'm hoping to have here is a 100-gram bracelet. That's 50% silver, which means at the end here, now, and this is the part that I think throws off a lot of people right down here. This has got, I actually know the exact amount of silver that there is in the final bracelet. If it's 100 grams, 50%, that means it's going to be 50 grams of silver. Okay? Now, the equations that I'm working from come from the first line and the last line. In many ways, this is really similar to the question that we did up here with the investment. Okay? So we've got a total mass here. Okay, x plus y is going to be 100. So here's equation 1. And then I've got my second equation is going to be 0.6x plus 0.35y, and this is going to equal 50 grams. So this is total mass plus total mass equals the total mass of the bracelet. Mass of silver plus mass of silver is the total mass of silver. But like we've seen in previous cases here, I'm not particularly fond of what's happening in that second equation. So what I'm going to do is I'm going to rewrite this system. Here's equation 1. X plus y is equal to 100. There's nothing wrong with that, but I'm going to multiply the second equation by 100. So that's going to get me 60x plus 35y is equal to 5,000. Okay, now this is in a form that I'm much more comfortable working with here. And I'm going to relabel these as equations 3 and 4. So now we just got to pick a variable to get rid of. Okay, we've been getting rid of y for the last couple. Let's get rid of x this time. So I'm going to multiply equation 3 by 60. Sorry, no, that's right. Sorry, equation 3 by 60. So it'll be 60x plus 60y is going to equal 6,000. And equation 4 is just going to be 60x plus 35y is equal to 5,000. Now, the coefficients are the same. They have the same sign. So it's going to be 60 times equation 3 minus equation 4. So the 60x's will disappear. 60 minus 35, okay, is going to be 25. Y, 6,000 minus 5,000 is 1,000. So we're almost there. Y is equal to, now I'm just going to make sure that I have been known to screw that up in terms of the number of zeros there. So y is equal to 40, so 40 grams. So once I've got that, I know, and I'm getting this from equation 1 now, okay, that the sum of those two has to equal 100, which means if I had 40 grams of the one alloy, I need 60 grams of the other. So the point that I'm looking at here is the point 60, 40. But I got to check that. I got that result from the first equation, so I'm going to check this in the second equation. So I'm going to check it in this one right here. Okay, so that's going to be 0.6 times 60 plus 0.35 times 40. Okay, and I'm going to go to my calculator to make sure that I do this correctly here. So that's going to be 0.6 times 60 plus 0.35 times 40. And would you look at that? I get 50. That is exactly the value that I was hoping to get, which means that is correct. So now I have to summarize my results. So he needs 60 grams, okay, of X. Now X was the 60% alloy. So I need 60 grams of the 60% alloy and 40 grams of the 35% alloy. Okay, and there you go. So hopefully you're getting a sense of how the method of elimination works. You have your two equations, you're going to pick a variable that you're going to eliminate, but you eliminate it by combining the two equations. So the thing that you need to do here is you need to pick a variable, and then you need to make sure that the coefficients are the same in the two equations. And that might involve multiplying the two equations by different values, okay, at the very worst, different values to make them the same. You have to remember to pay very close attention to the signs, because it's sign errors that will cause the biggest problems here. If they're both negative, you have to use subtraction to cancel those that variable out here. And that takes a little bit of getting used to if you're not 100% comfortable with negative signs there. So anyway, there you go.